Hello guys, welcome back. This side Lakshit, and today we are mainly going to discuss about two's complement, ASCII table and loops. So before discussing about two's complement, let us discuss about data types. There are mainly five kind of data types: int, bool, char, float, and double. Int is used to store an integer. Bool, boolean. It is called boolean and it is mainly used to return true or false. True or false. False is 0 and true is anything other than 0. Usually it is taken as 1, but any integer not equal to 0 is true. Character, it will store any type of character: A, B, C, D, hashtag, star, anything. Float, float and double. Both are used for decimal, something point dot decimal. But the difference between float and double is lies in its precision. Double has twice the precision, twice the precision as of float. If a float represents 2.123, then double can represent 2.1234566. It has a precision double than that of float. This was all about data types, which is basically used to store something. And it is obvious that let us discuss something about size. So the sizes are mainly of importance are of integer, char and bool. So size can vary as per the computer, but there are two standard sizes generally used. For integer, it is either 4 bytes or 8 bytes. What is a byte? One byte, it is equal to 8 bits. So therefore integer is equal to either 32 bits or 64 bits. What is a bit? Consider bit as a box. As you know that computer stores everything in binary, which means 0 or 1. So bit is the smallest possible box and it can either store 1 or 0. So what does 32 bit means? That suppose this is the memory And when we have declared integer x, our 32-bit memory is allocated for integer x. As 32-bit is quite large, let us discuss it for 2-bit, suppose. So, what is the largest possible number? Let us discuss. So, considering 1 bit can store either 0 or 1. So, the largest possible number is 1. And for, let us take 2 bit. So, it can store 00, 01, 10, 11. These are the possible ways. This is equal to 0. This is equal to 1. This is equal to 2. And this is equal to 3. So in another video I will discuss how to convert binary into decimal. How 00 represent 0, 10 represent 2. For you can use this shortcut as of now. Suppose it is a unsigned bit, unsigned integer. Suppose, let us suppose. I will discuss what is this unsigned and signed in this video only. So each bit in this is a multiple of 2. It is 2 to the power 0. It is 2 to the power 1. It is 2 to the power 2, 2 power 3, 2 power 4, 2 power 5 and so on, 2 power n. So how to represent a number? Suppose this is a bit 0, 1, 1. So what we have to do is the weightage of this bit is 2 power 0. It is 2. It is 4. So decimal number is equal to 0 into 2 to the power 0 plus 1 into 2 plus 4 into 1, which is equal to 6. So this bit represents 6. It is simple. Bit value into weightage summation. Adding bit value into its weightage and then taking a summation. So 2 bit can represent coming, the maximum value it can store is 1 1, which is equal to 2 to the power 0 into 1 plus 2 into 1, which is equal to 3. Let us take 3 bit. It can maximum store 111, which is equal to 2 to the power 0, 2, 2 square, 4 into 1 plus 2 into 1 plus 1, which is equal to 7. You can clearly notice that it is equal to 2 to power n minus 1. You can see if it is 2 bit, it is 3, 2 square minus 1. If it is 3 bit, it is 2 cube minus 1. You can also derive this equation. So for maximum value, every bit should have 1. should have 1, right? Let it is a big bit. Every bit has 1. So what will be its value? Its value be equal to 2 to the power 0 plus 2 to the power 1. Let it be n bit. So it is 2 to the power 0, 2 to the power 1, 2 to the power 2. If these are total n bits, then last bit will have 2 to the power n minus 1. Because you can see that the first bit has 0, second bit has 1. So nth bit will have n minus 1. So the value will be equal to 2 power 0 plus 2 power 1 plus 2 power 2 till 2 power n minus 1, which is nothing but a GP. And we know that the formula of GP is A R n minus 1 by R minus 1, where A is the first term, R is the ratio, and n is the nth term. So summation will be the first term is 2 power 0, which is equal to 1. Ratio is 2 to the power n minus 1 divided by 2 minus 1, which is equal to 2 to the power n minus 1. Hence we have proved that an n bit can store a maximum number of 2 to the power n minus 1. Similarly, coming to the point, integer will either store 32-bit or 64-bit depending upon the computer, and 1 byte is equal to 8 bits. Hope you have got a clear idea of integer. And one more point I will discuss about it quite later. Coming to character. Character, in almost all the computers, the memory stored by the character is 1 byte, which is equal to 8 bits. And let me tell you a point. Minimum memory allocated by the computer is 1 byte. Do remember this point. Minimum memory allocated by the computer is 1 byte. Okay, coming to the bool. So bool has either represent 1 or 0, as I have discussed. 1 for true, 0 for false. So ideally thinking, we can we only require 1 bit, 0 or 1, to store 0 and 1. But as discussed above, minimum memory allocated by the computer is 1 byte. So memory, or we can say size of bool, is 1 byte. We will also practically see what output a compiler gives. So let us see what the compiler gives as an output. Okay, so this is online GDP, and we have discussed about this quite later. And coming to the point, to get the size, there is a predefined function called size of, and we are going to use the same only. So see out double quotes, the size of int is, size of is the function int, and then endl to end the line. See out, the size of char is size of char handle. See out, the size of bool is size of bool handle. And let me run this program. You can clearly see that the size of int is 4, size of char is 1, and as I said that memory minimum memory allocated is 1 byte. The size of bool is 1 byte only. So this was all about the size, and let me come to discuss about the 2's complement. So what is 2's complement? Basically, to store negative numbers, 2's complement is used. So 2's complement in every computer, 2's complement is used by default. So the problem was that what if, as we know that every bit represents, or every bit contains 0 or 1. So how to differentiate between negative and positive numbers? This was the question. How to store them? So the method which was finally accepted was 2's complement, and let us start discussing about it. So what it does is it has a weightage of 2 power 0, it has a weightage of 2 power 1, it has a weightage of 2 power 2, it has a weightage of 2 power 3 similarly, but the last bit has a weightage of minus 2 power n minus n. If it is a n plus 1 bit, minus 2 power n, because the maximum power will be 1 less than the number of bits. Only this term will be negative. Let me give a simple example. Suppose suppose it is a 3-bit. This is has a weightage of 2 power 0. It has a weightage of 2 power 1. It has a weightage of minus 2 power 2. I hope you got understood what I meant to say. So 3 will be stored as 0, 1, 1. Now to get minus 3, what is the actual way? Take complement of it. Complement means reversing the value in bit. So reversing the value we get 1, 0, 0 and add 1 to it. Okay, let me tell you the addition of bit. 1 plus 1 is not equal to 2. It is equal to 1, 0. 1 will go as a carry to next bit. 1 plus 0 is 1. 0 plus 1 is 1. This is so because bit can't store 2. Bit can only store 0 and 1. So it will 1 will go as in carry like 1. If it is a 2 bit, adding 1 we will get 1 plus 1, 1, 0, 1, 1, 1, 0, 0, 1, 1. This is the way we use to add. So what we have to do in 2's complement is simply add 1. So we get 1, 0, 1. And you can verify this result with weightage method. So using weightage method here only, it has a weightage of minus 2 power 2. It has a weightage of 2 power 1. It has a weightage of 2 power 0. Adding 1 minus 4, which is equal to minus 3. 1 of this minus 4 of this. We get minus 3, and hence it is a way of representing minus 3. This is 3. Sorry, this is not 3. This is 3. We take complement of it and then we add 1. Let us take another example. Suppose we store 5. So 5 is stored as 1, 2 power 0, 2 power 1, 2 power 2, 2 power 3 and minus 2 power 4. So 5 is stored as 1 plus 4 and rest all 0. Okay, so now we have to calculate minus 5. So what we will do is take complement of this 1, 1, 0, 1, 0 and add 1. Add 1 at last. What we get is 1, 1, 0, 1, 1. And let us verify this. So 2 power 0, 2 power 1, 2 power 2, 2 power 3, minus 2 power 4. So we have to add minus 2 power 4 plus 2 power 3 plus 2 power 1 plus 1. So minus 16 plus 8 plus 2 plus 1. And this is 11. So minus 16 plus 11 is equal to minus 5. So this is a way of writing minus 5. Now, now let us check for 0. So ideally 0 should be this. And let us verify it by adding. Suppose it is a 5 bit 1 2 3 4 5. So let us solve this by adding minus 5 plus 5. So we have written minus 5 here in the 5 bit. 1 1 0 1 1 0 1 1. And we can write 5 as 0 1 0 1 0 0. So now adding both of them, we get 1 plus 1 1 carry 0 here, 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 1 plus 1 1 carry 0 here. And now as we can see that there is no more memory allocated, this will be discarded and we will get 0. So there are many other ways of which were used to represent negative numbers, but they were discarded because they were contradicting the value of 0. There used to be one's complement, which I will not discuss here. So this is a way why two's complement is used and how it is given weightage. Hope you remember this point. So now we have discussed about the data types and two's complement. Coming to the ASCII table. So what is ASCII table? Some values has been predefined for every character. This value is called ASCII value. Like A has a value of 65, capital A, and similarly other character have other values. So let us see the ASCII value table. So I have googled ASCII value table and I have opened this image. This is not a much clear image. Let me copy it. So you can clearly see that every character has been assigned a particular value in decimal. These are the character, null character, or any characters. The main value which you must remember is 0, 48, and you can remember 9 because they are all in increasing order in a particular order: 48 plus 49, 50, 51, 52, 53, and so on till 9. Another you must remember is of A, 65, to 90, the value of z. And these ASCII values are assigned in different languages like hexadecimal, octadecimal, but in computer it uses decimal value. So you must remember that value only and ignore this part. And last, what you must remember is of a small a to small z, 97 to 122. These data are important. So this is all about ASCII table and it is very useful. We will discuss some examples later. Now let us check the ASCII value, whether the ASCII value is coming correct or not. Let's open the compiler. So as we know that ASCII value is an integer, so we will use an integer to store it. Let integer be x and ASCII value, we get ASCII value with single quotes. Let it be a and let me do cout x. Let me run this. We can clearly see that it is 65 and we can verify it that the ASCII value of a is 65. We can also check out it for small a, maybe let it be small a. So it is coming out to be 97 and you can see that it is 97. And also remember that ASCII value starts from 0 and adds 127. So all the characters have their ASCII value between 0 to 127, which clearly show that there are only 127 characters existing in the world of computer. So moving forward, let us discuss about loops. So basically there are three important loops: if loop, while loop, and for loop. We will discuss these three loops in today's video. So what is an if loop? So the syntax is nothing but a rough body, like how if works. So if condition bracket close, open bracket, close bracket. If this condition is true, if this condition is true, this code will be executed. This code will be executed. So writing it exactly, if this is true, this code will be executed. Else, if this condition is true, this code will be executed. So you can use else if as many times as you want. Else if this is true, this will be run, and in last it is else. So what does else means is that if this condition is false, this condition is false, and every other possible condition are false, then this will be executed. So let us discuss it, and let me tell you about some conditions to check whether something is true or not. Like if I assign integer x is equal to 5, so later on if I have to check, so the operator is equal to, you have to do x equal to 5 or maybe any number y. If you want to check whether x is equal to or equal to y, then you have to use this. Using x equal to y means that you are assigning the value of y to x. Let me, I will discuss it more briefly when I will apply it practically, but understand it theoretically. Suppose y is 4, x is 5. What happens is that you x equal to y, the computer checks that is 5 equal to 4, in this case y index, and return true or false. What happens when you assign x equal to 5? It allocates the value of 5 to x equal to y. What it will do that the value of y will be given to value of x. It will not check, it will assign. So let us see the if operator. So using if loop and equals to operator. So let me declare an integer x, and I take the value of x as an input. So what I will do next is if x is equal to 5, I will do cout x, the value of x is 5, else if x is equal to 4, cout, let me just copy it, control C, 4, else if x equal to 6, the value of x is 6. And finally let me use else. Remember that there is no brackets, open brackets in else, because we don't have to check any condition. We will simply every another condition not followed here will be true for else. Cout the else is The else has ran here. So let me just run it. So suppose I give the value of x equal to 4 and press enter. So what happens is that first of all x is x equal to 5? Computer says no. So it goes to else if is x equal to 4? The answer comes out to be true. So it enters the loop and prints the value of x is equal to 4. Suppose let me again run this program. Let me enter the value of equal to 6. So what will happen this time is that is x equal to 5? No. If is x equal to 4? No. Is x equal to 6? Yes. Then this code will run. Let me again run and let us test the else. So let me give some random number 67, 677. Let me and then let me press enter. The else has ran here. So is it true? No, false. It is also false. It is also false. So else will run here and it will be printed. Now what I do is that let me remove the checking operator and let me assign the value of 5 equal to x. And let us again run this. And let me give it some value, let us say 87. So what will happen? The value of x is y, 5. Ideally, else should have been run because the value of x is 87. So what has happened here is that this has assigned the value. The value is assigned here, not checked. So be remember that value of x is assigned to be 5. So it is true. And if it's true, this will run. And I can make you sure. Let me again, what I do, let me do cout x. And let me make sure that it is outside the loop. And let me do x and let me also add endl here so that a new line should begin. So let me enter any value, let 56. The value of x is 5 and outside the value value of x is 5. Let me I have just corrected the space here. Let me enter 56. Let me press enter. So outside the loop the value is 5 and the value of x is 5. So I hope you must have now got a fair idea how if is run. Similarly, there is another loop called while loop. So what happens in while is that while condition brackets. So while condition till this condition is true, the loop will run. This code will always get executed till the condition is true. So let us check this. There is nothing more in while loop. So let me just refresh it. So let integer is t and we take input c and t. So while let me give the condition t is greater than 0, see out the value of t is t and let me handle. So let me run it. So sorry, we have not, there is an error in this. So what will happen in this condition is that we have not anywhere decreased the value of t. So it will go continuously. Like what will happen is that, sorry, while t is greater than 0, this loop. So I have entered cout t handle. So t is 5. What will happen is that this will execute the code, then it will again check the condition which is true, then this will again run the code, then this will again check the condition. So it will keep on going because we are not anywhere changing the value of t. Until the value of t is less than or equal to 0, this loop will not stop and it will keep on going. So what we will do is we will do t minus t equal to t minus 1 and let us see what happens. The value of t, let it be 5. So see, the first of all, 5 is greater than 0, so the value of t is 5. Then t will be changed to t minus 1. Now the loop will come here. Let me also add one more thing. Cout loop ends and L cout loop begins to make sure that it is again and again entering the loop. So let me again give the value 5. So what happens? Loop begins, the value of t is 5 and then loop ends. There is nothing more done here. Now again the program computer checks the value that is t still greater than 0. The value of t is 4 after this part has been executed. So yes, 4 is greater than 0. Again this whole loop will run. Again this whole loop runs. Now the value of t is 3. So computer checks, is it greater than 0? Then computer says yes. Then this again gets printed. Similarly for 2, similarly for 1. Now what happens when the value is 1? Then it gets decreased to 0. Is 0 greater than 0? Computer says false and then it returns and then the loop ends finally and return 0 is executed. Let me add one more thing. Cout we are out of loop and let me enter the value 5 and you can see that as soon as this last loop ends we are out of the loop. This part is executed and finally we return and all the memory gets destroyed. So this is how while works. We will discuss a lot of questions related to if, while and for loop in the future videos. Now let us discuss one last loop, for loop. So what is for loop? For something comes here, semicolon, something, semicolon. Let me discuss, I will discuss what is semicolon. Stops. The loop is executed. For loop is basically while loop. It is modified version of while loop. So what is there that initial condition? Here we put initial condition. Condition we check those the same condition which is checked here. This condition and changes to be made. We used to write in the end t is equal to t minus 1. So this condition, this change is written here above only, which reduces the chances of error. Because I also forgot to add this, so it will give an error. So to avoid the error, 4 is preferred. While but still also while has its own benefits, we don't need to require give any initial condition and is small to write while 4 is very heavy to write. So let us check the application of 4. So let me remove this. So let me declare an integer I. So what happens is that for I equal to 0. This is the initial condition. I have assigned. Remember, I have not checked, I have assigned that I is equal to 0 initially. I less than 5. This is the condition to be checked. And then I do I is equal to I plus 1. This is the changes I am making in I. I will do C out I and then C out, let me beautify it. The value of I is, so let me run this. You can see. So first of all, I is equal to 0. I is equal to 0. So the computer will check is I is less than 5, 0 is less than 5 true. So this will go inside. It will print the value of I is 0. Now I is changed to I plus 1. The value of I becomes 1. Computer checks is I is less than 5, 1 is less than 5 true. Again this is run. Then again value of I is changed to 2. And again it is checked is it less than 5, it is true. So as soon as this reaches 4, as soon as the value of I reaches 4, what happens is that value is changed to 5. Is value less than 5? Is 5 less than 5? False. So the loop ends. We are out of loop and we forgot to write return 0, which and it is not necessary to write return 0, like computer is smart enough to understand. So we are out of the loop. See, after, and one more thing, let us just also print the value of I. You can see that the value of I is 5 because when it came out of the loop, the value was 4 and 4 was incremented to 5 and it was checked. Is it less than 5? So answer was no. So the value of I was 5 when it came out of the loop. You can check, you can see here. So we have completed all the 3 loops, and in the coming videos we are going to discuss problems to this and we will discuss a lot of problems and optimizations and some questions to increase thinking capability as we have discussed our glass problem. So today we have discussed about ASCII value, 2's complement. I can also make a separate video on the types of value stored and different ways of complement, one's complement, two's complement. I can make a separate video if you want. And we have discussed the loops and data types, the size of the data types, and the minimum value. 1 byte is equal to 8 bits, and normally the value of integer is 32 bits. What is a bit? What is unsigned? Unsigned means that the last bit has a positive value. There is no negative value assigned here. And then we discussed loops. And then we also discussed two's complement and verifying to get a 0. Then we discussed ASCII value, ASCII table. And then we discussed the for loop. Thanks for watching the video. Hope you liked it.